Hello guys, very good evening and welcome to the BYJU'S Exam Prep, the most comprehensive app for all competitive exams. How are you guys? Let me know that sound quality, picture quality, everything is fine. And today we are going to discuss important questions, that is previous year questions from 2018, 19, 20, 21 and 2022. And we will cover questions from electronics, electrical and instrumentation branch. तो ये सेशन बहुत ही ज़्यादा इंपॉर्टेंट होने वाला है, तो प्लीज़ लाइक द सेशन, शेयर द लिंक ऑफ दिस सेशन एंड सब्सक्राइब आवर चैनल. ओके, आई थिंक यू हैव रिवाइज्ड द एनालॉग फॉर गेट 2023. नाउ you will get the idea about the questions and how to solve the question during exam, right? And what about the repetitive nature of the concept? And sometimes we are getting the similar type of question with different data only. Okay, that's why the previous to solve the previous year question is very important one. So let me know that sound quality, picture quality, everything is fine. तो start करते हैं हमारा session without any delay. I think everything is fine now. Okay. Okay guys, now this is for GATE 2023 exam previous year questions analog part 1. Already we have divided it into two parts because we have to solve what number of questions. So Chandrasekhar, very good evening. Ramakrishna, Ravi Shankar or Rama. Okay. Now, because we have to solve number of questions from 2022, 21, 20, 19 and 18 from three branches, means what electronics, electrical and what instrumentation, right? I will try to cover almost all the question here, right? Okay. And remember, I will give you the idea of same type of questions in previous year than same question in 2022 and 2021 and 2020. Okay. So dekhte hain zara. That is my introduction. Myself Sanjay Rathi. I am having around 21 plus years of teaching experience. And I have mentored more than 1 lakh students for these competitive exams like EAC, GATE and other PSUs. I have qualified and selected for engineering services exam. In 2005, my rank was 16 and in 2008, my rank was 21. And these are my subjects. Then tomorrow at the same time, 6 p.m., please note this time, I am going to take the second part. Again, we will solve remaining question of analog as a part 2 tomorrow 6 p.m. sharp. If you want notification, then subscribe our channel, right? And try to attend what GATE AIMER'S series also. That is just like what crash course, and you will get the command over the basics and important theory point. Okay. Then this is for you GATE previous year questions. Continuously we are taking all the subject, and that already we have started from 18th December. Digital is over, control is over, EDC over. Now what? Analog part 1 and then part 2. And if you want to start your preparation for GATE 2024, then that is for you 90% scholarship on preparation program. Then 24th December at 8 p.m. You can register on our official website, that is BYJU'S Exam Prep on app. Okay, so that is a good opportunity for you, and you are going to get the 90% scholarship. Then that is the first question in GATE 2022, my dear students. That is a question on what MOSFET. That is simple on concept of biasing, right? On concept of biasing in GATE 2022, but it is a very conceptual question. What is the answer for this one? Right. One by one you will get the idea about the MOSFET, idea about the operational amplifier, BJT biasing and stabilization, questions on amplifier, on all topics, diode, voltage regulator, Schmitt trigger, waveform generator, different types of question in last 5 years. Okay, all important topic will be covered here. Now the ideal long channel and MOSFET. लेकिन एक बार जरा आप ओके, अभी अपने सभी फ्रेंड्स को बुला लीजिए. अब ये सेशन स्टार्ट होने वाला है और स्टार्ट हो चुका है. ये पहला क्वेश्चन है और पहले क्वेश्चन के साथ हम लोग इसे स्टार्ट कर रहे हैं कि कैसे हमें क्वेश्चन बनाना होता है. नाउ द आइडियल लॉन्ग चैनल N MOSFET and P MOSFET devices shown in the circuit have threshold voltage of 1 volt and minus 1 volt. This is a very basic thing, right? So number of students are wasting time in reading these lines. So simply what is the information here? Threshold voltage is 1 volt and for P MOSFET it is minus 1 volt, P channel MOSFET. Very simple, positive and negative. The MOSFET substrate are connected to their respective sources. Again, this point is what? Redundant. Okay, in every MOSFET we are connecting the body to what? Source. To make the source body junction reverse bias. That is a normal practice. Okay. Ignore leakage current and assume that the capacitor are initially discharged. This is important. When we are neglecting the leakage current means we are saying that Ig is equal to what? 0. Or when the MOSFET is in cutoff, there will be no current. Capacitor is ideal, MOSFET is ideal, Ig FET, that is insulated gate field effect transistor, and that's why Ig is equal to what? 0. So, okay, we are considering ideal condition. Now, which point is important? Only one line is important. Initially, the capacitor is discharged, and for the applied voltage as shown, the steady state voltages are. Steady state condition we have to calculate, right? This point is okay. Then what is your question? Avalanche has positive sign means what? Positive temperature coefficient. Avalanche breakdown voltage has positive temperature coefficient and Zener has negative temperature coefficient. You are talking about positive sign. What is the meaning of the positive sign? Then for the applied voltage, okay. So steady state means here we are having the DC, here we are having the DC. So under steady state condition, for DC signal, capacitor acts as open circuit. That is the basic concept. Okay. Now, how we are going to solve this question? First MOSFET is, because there is no bubble, this is the N channel, N MOSFET. And there is a bubble, means it is a PMOS. Okay. Then first is what? NMOS. So what will be the voltage? Remember, VGS should be for NMOS. VGS should be greater than VTH. Otherwise, it will be in cutoff. If VGS is less than VTH, means that transistor will be in cutoff. Very, very basic concept. Then what about this terminal? This is the source. This is the source. This is the drain, and that is the gate terminal. Draw the diagram. Here we are connecting the capacitor. Here we are giving the 5 volt. Right? Here again we are connecting the 5 volt. Okay. Now we want voltage at this point V1. What is the under steady state? The capacitor will act as open circuit. So what will be the current here? This is the capacitor. Now we have to maintain minimum threshold voltage here, 1 volt. VGS should be greater than or equal to VTH, means what is the minimum value of VGS? 1 volt. So when the VGS is minimum, we are getting the maximum voltage across the capacitor, right? Why? Because what is the voltage across the capacitor? V1 is equal to 5 minus VGS. 5 minus VGS minimum. 5 minus 1, that is equal to 4 volt. So V1 is 4 volt. Okay, it means the capacitor charge up to what? 4 volt. Once the capacitor charge up to 4 volt, MOSFET will be in cutoff. MOSFET will be in what? Cutoff, right? And that's why what is the maximum voltage here? 4 volt. Now in case of P MOSFET, in case of P MOSFET or P channel MOSFET, now this is the case. Here it is connected. Here we are taking the V2. Now this point is 5 volt minus 5 volt. And this is the 5 volt. Remember, this is the source terminal actually. And that is the drain terminal. And this voltage is called VSGP. VSGP. This is the voltage for what? P MOSFET. And this VSGP should be greater than or equal to what? Mod of VTP. So that there will be the current. There will be the current. When there will be the current, the capacitor will charge. Right? Right. So what is the final value? Finally, what is the maximum voltage? The maximum voltage is 5 volt, and that's why in this case, this capacitor will charge up to what? 5 volt. Because it will not affect the VSGP. VSGP will remain 5 minus of minus 5, that is equal to what? 10 volt. It is always greater than what? Its threshold voltage. Why we are putting the mod? Because it is a PMOS. Always remember, we have to make the threshold voltage positive. Right? When we are changing the subscript, you have to make it positive. Otherwise, the VTP is negative 1. Minus 1 volt. When we are putting mod, it will become positive, and VSGP should be greater than or equal to 1 volt, and it is greater than that 10 volt. And that's why, in this case, the capacitor will charge. Under steady state, it will act as open circuit. There will be the no current, right? And we are getting the 5 volt here. So what is the answer? V1 is 4 volt and V2 is what? 5 volt. V1 maximum voltage 4 volt and V2 maximum voltage is 5 volt. Yes, Mohan, your answer is correct. Ravi, Shankar, Kirti, क्या हुआ भाई? किस बात के लिए सॉरी हो? कोई बात नहीं, क्या पूछा आपने ऐसा? ओके देन, चलेगा. अब आते हैं नेक्स्ट उस पर. नेक्स्ट क्वेश्चन जो है बहुत तेजी से हम लोग सॉल्व करेंगे. तो ये तो हुआ मॉसफेट पे. दूसरा ये क्वेश्चन मैंने for this solution of this question, you can watch my session on what EDC. Okay, in EDC there is a overlapping of the syllabus, but electrical student, how many students are from electrical and instrumentation branch? You can expect this type of question in what? Analog also. No doubt, when we are dealing with the biasing or simple question on that, so at the last I will solve it. At the last I will solve it. Otherwise, already I have uploaded the PDF on my Telegram channel, that is Electronics by Sanjay Rathi. Oh, Bharat Raj, you are from instrumentation branch. You are from electrical. Okay then, no issue. So that is the solution for this question is available there. At the end, I will solve it. Okay then. Then already I have taken one session on my Telegram channel. Links are available. Go through that for this particular question. Now the third one. Third question is an ideal operational amplifier circuit with a sinusoidal input is shown in the figure. This is the sinusoidal. Here we are giving the sinusoidal input. The 3 dB frequency is the frequency at which the magnitude of the voltage gain decreases by 3 dB. Yes, we have idea about that. From the maximum value, which of the option are correct? Right. It is a standard circuit of what? It is a standard circuit of high pass filter. When this 2 kilo ohm is connected here, when this 1 kilo ohm is connected here, when one capacitor is connected here, that is nothing but standard circuit of high pass filter. Okay, so what is the basic circuit? This is the modification of this circuit. This is the modification of this circuit. This is RF, this is C, and here we are giving the input. It is nothing but a differentiator. This is a differentiator, right? But what is the problem with this circuit? Problem is simply what? For DC capacitor act as open circuit, and for infinite frequency, what is the impedance of the capacitor? 1 by omega C. When the frequency is infinity, ZC will become 0. What is the problem? If the ZC will become, what is the problem then? The problem of this circuit is RF by ZC. What is the gain of the system? The gain of this is, magnitude of the gain is given by RF by mod of ZC. Minus RF by ZC, but I am just getting the magnitude. At omega is equal to infinite, this will become 0 and we are going to get the gate infinite. We are going to get the gain infinite, and that's why this circuit is what? Unstable. So just I am giving you the information about that. This is a modification of this circuit. This is a modification of this circuit, and that's why to make the gain finite at omega is equal to infinity, we are putting one resistor here, R1. We are connecting one resistor here. So what will be the question in 2023? We can expect standard diagram, question on the same concept, on same diagram. We can expect one question. Why we are connecting R1? This is the circuit. but practically we are not using this circuit. What is the problem with this circuit and why we are connecting R1 here? So when we are connecting R1, the gain will become finite. What will be the gain now? So gain means, okay, now at omega is equal to infinite, this capacitor will act as short circuit. When this capacitor acts as short circuit, this is the R1. So what is the omega equal to infinite? The maximum gain will become RF by R1 only. The maximum gain of this circuit is RF by R1 exactly at omega is equal to what? Infinity. And at omega is equal to 0, ZC is what? Infinite. And that's why the gain is what? 0. So at low frequency, the gain is 0. At high frequency, gain is maximum. Means it is nothing but a high pass filter. So high pass filter. And what is the cutoff frequency for high pass filter? This is important parameter. This one is the important parameter, 1 by 2 pi R1C. तो ये किसमें पूछा है भाई? 3 dB frequency is radian per second. If it is radian per second, then cutoff frequency is simply given by 1 by R1C. This one, R1C. Put the value of 1 kilo ohm, put the value 1 microfarad, and you will get the 1000 radian per second. 1000 radian per second. So this was the MSQ question. Last time almost 14 question as MSQ, 14, 1-4, right, in electrical branch, in electronics branch. So why 1-4 questions? So this time we may expect what more than that. So MSQ. So which answers are correct? Circuit is a high pass filter. 3 dB frequency is 1000 radian per second. Okay. In next time we can assume what is the role of R1 in particular circuit. Okay, then next one. ये था 2022. थर्ड क्वेश्चन, कोई भी डाउट है तो आप आराम से पूछिएगा. कोई भी आपके दिमाग में अगर किसी चीज को लेकर कोई भी डाउट आता है तो यस यू कैन आस्क. ओके, नाउ for the following circuit with an ideal op-amp, the difference between the maximum and the minimum value of the capacitor voltage. Maximum and minimum value of the capacitor voltage. Okay. Tell me from last 20 years, 5 to 6 times question on what? High pass filter. And from last 20 years, question from electrical electronics instrumentation branch. Please watch the previous year question carefully. Number of times question on what? Astable multivibrator, and that is nothing but astable multivibrator. Astable multivibrator means square wave generator. We are not connecting any input here. So here every time there will be the question. Now what about the characteristics of the diode? Here the characteristics is given. At the 0, suddenly the current will increase. Means this is nothing but an ideal diode. When it is forward bias, it will act as short circuit. Or when it is reverse bias, it will act as what? Open circuit. Very simple. So that characteristics is given exactly at 0, the current will increase. When this type of characteristics means that is the ideal diode. Okay. And this is nothing but a stable multivibrator, or we can say square wave generator. Square wave generator. So next time we can expect one MSQ. For example, what was the in previous question? What is the name of this circuit? So what is the name of this circuit is what? The circuit is a high pass filter. What is the second question? The 3 dB frequency is 1000 radian per second. Okay. MSQ. So what will be the MSQ next time? What is the name of this circuit? It is a astable multivibrator. Another name of this circuit, it is a square wave generator. Another name of this circuit, it is a free running multivibrator. And last option, what is the difference between the maximum and minimum value of the capacitor voltage? Right. तो आप देखते हैं इसमें क्वेश्चन तो एक ही पूछा है, लेकिन तो चलिए हम बनाते हैं. Now redraw this circuit. Redraw this circuit and you will get the idea about that. तो give me 1 minute. चलिए इसको सेट कर लेते हैं. अब आते हैं हमारा जो बैकग्राउंड कलर ले लेते हैं हम लोग. ओके. Now, what is the standard circuit here? We are having the 4 resistors. Here we are having the feedback, positive feedback. We are having one capacitor here and one resistor here. Redraw the circuit. This is the R and that is what C, and here it is connected to ground and that point is connected to ground. Now, one diode is connected parallel to this R, and what is this? This is the V0. Towards V0 it is negative terminal, towards this it is a positive terminal, and then we can connect one diode here. Okay. Second important thing, one diode is connected here, positive, this is positive terminal is connected to positive, we can connect a positive terminal. One diode is connected here. That is the diagram, alright. And remember one thing, what is the supply voltage? 15 and minus 12. So normally students are assuming that if it is the 15 volt, then it will be minus 15 volt. No, that is not necessary. 15 or 0, 15 or minus 12, 15 or minus 11, 15 or minus 10. Yes, positive voltage is maybe equal to what, negative, or it may be different. Okay. Now, because there is a positive feedback, output, this is simple VB, this is called positive terminal voltage, that is called negative terminal voltage. Because there is a positive feedback, dominance of the positive feedback, therefore VB, if the VB is greater than VA, the output will be plus 15 volt. That is called plus V set. If the VB is less than VA, there will be the minus 12 volt. This is called minus V set. There will be only 2 outputs in this diagram. This is a standard circuit. Okay. Now you have to find the threshold voltage at this point. When the V0 is positive voltage, what about the position of diode D1 and what about the position of diode D2? So when it is a 15 volt, because of this 15 volt, this diode is reverse bias and that's why it is off. And this diode is forward bias, that's why it is on. Now, once it is off, this resistor will be in action, this resistor will be in action. This is short circuited because it is ideal diode, that resistor is short circuited, and that is the case. R, because this resistor is already short circuited. So what is the voltage at this point? VB. Because what is the current enter into the operational amplifier? 0. Remember, the input resistance of the op-amp is infinite. That's why the current in this branch is 0. Now, what will be the voltage at this point? According to voltage division rule, if this is the 15, then that voltage will be what? R divided by 3R into what? 15. R divided by 3R into what? 15. Then this will become 5 volt. This will become 5 volt. तो देखिए क्वेश्चन क्या पूछा है, the difference between the maximum and minimum value of the capacitor voltage. तो ये तो आ गया 5 volt, ये आ गया आपका 5 volt, ये हो गया एक threshold, एक हो गया threshold, right? Then second one. अब उसके बाद आता है second question. Second इसमें डायग्राम देखिएगा. आप देखिए, एक तो आ गया 5 वोल्ट. जब आप दूसरा केस लेते हैं, it is a minus 12 volt. Because of this minus 12, this D1 is on, D2 is off. Then this is on. This is on. It will short circuited. This resistor is short circuited. We are considering this resistor, this. Now, where is the VB? Here it is the VB. We are considering 2 resistors here. R, and this R, and this is minus 12 volt. This is short circuited by the diode, R, and that is the VB. Now, this time what is the VB? VB is equal to 2R upon 3R into what? Minus 12. This is cancelled out and it will become minus 8 volt. it will become minus 8 volt. So what is the upper threshold level? Minus 8 volt. And what is the lower threshold voltage? Upper threshold voltage is what? 5 volt. 5 volt. And lower threshold voltage is minus 8 volt. Now remember one thing. What is the standard about this circuit? Last year there was one question on in 2021. Again we are going to solve that particular question. So remember one thing. Once you will get the idea about the upper threshold and lower threshold, now what is the voltage across the capacitor? Highest level is 5 volt, lowest level is minus 8 volt, right? Now the capacitor will charge from minus 8 to 5 and then 5 to what? Minus 8. When it is charging, up to this point, and when it is discharging, then at this point output will be plus 15, and when it is discharging, output will be minus 12. We are getting this type of square wave. This type of square wave. Okay. So what is asked here? So this is the 15, 0, minus 12. That is the output, and this is the voltage across the capacitor. Capacitor will charge from minus 8 to plus 5, 5 to minus 8. Now, what is the question asked here? The difference between the maximum and minimum value of the capacitor voltage, right? So difference between the maximum and minimum, 5 minus of minus 8, it will become what? 13. This is the 13 is the answer for this question. The gap from this point to this point. Okay, this is over. Any doubt? अब देखो similar question ना, repetitive nature देखिए, इसी topic पर same type of question. देखिए, this is the voltage across the capacitor. Now what will be the next question on the same diagram? This is the voltage across the capacitor. Okay, what is the voltage? What is the maximum and minimum? Everyone tell me, give me the answer in the comments box. What is the difference between maximum and minimum voltage at this point? At the positive terminal. This is the nothing but negative terminal voltage. That is nothing but the voltage across the capacitor. Already we have taken 13 volt. So what is the maximum and minimum difference between this point? This will be again what? Same. That is what? 13 volt. But here we are going to get what? Square wave. Yes, Murli, your answer is correct. But here we will get the square wave. At this point we are getting the square wave. At this point we are getting the square wave. The maximum value is 15, minimum value is minus 12. But at this point the maximum value is what? 5, minimum value is minus 8. But here we are getting the approximated triangular wave. This is called approximated triangular wave, exponentially charging, exponentially discharging. Again it will charge, again it will discharge like this. This is all about this question. Okay. Now I will solve one similar type of question on this diagram in give me 1 minute only. Dekhiye. This will give you the confidence. We are getting the same type of question. In electrical branch, light, now this one. Okay. In 2014, please watch the paper. In 2014, same question. But only difference in what data? In similar in 2021 electrical branch, this is the question. In 2014, similar question on this particular diagram, right? What is the question here? CMOS symmetry triggers inverter has a low output level of 0 volt. Now this time the low output voltage is 0 volt and a high output level of 5 volt. Okay, this time it is 5 volt is given. It has the input threshold of 1.6 and 2.4 already, but nothing. R1, R2 is not connected. R1, R2 diode is not connected. Direct threshold voltage is given 1.6 and 2.4 volt. The input capacitance and output resistance of the CMOS trigger are negligible, ideal circuit. The frequency of the oscillation shown in the figure, right? 2022 similar question, 2021 similar question in electrical branch, 2014 same to same question in electrical branch. Now, how we are going to solve this question? CMOS trigger inverter has a low output level of 0 volt and high output level of 5 volt. So we are having the 0 and 5 volt. Threshold voltage already given, so no need to calculate the threshold voltage. Then how we are going to solve it? Simply make a diagram. What is the voltage across the capacitor? Now, what is the threshold level? 2.4 volt and 1.6 volt. Okay. Sorry. This is 0 level. This is 1.6 volt. This is 2.4 volt. Right. Now the capacitor will charge between 1.6 and 2.4 volt. This is the upper threshold, lower threshold level. Now, so what is the voltage across the capacitor? Like this. Okay. It will charge towards what? 5 volt, because the maximum voltage is 5 volt, and it will discharge towards what? 0 volt. So what is the final value? 0 volt. Right. Now, it will charge up towards 5 volt because it is given. When it will charge the output voltage, what about the output voltage? Please watch this diagram. When it will charge, the output voltage will be 5 volt. When it will discharge, the output voltage will be 0 volt. Okay. And so on. So this is a square wave 5, 0. Now from 1.6 to 2.4, again this is a very lengthy question. You have to find the equation. Then you have to write one equation. What is the voltage across the capacitor? V final minus V final minus V initial e raised to power minus t by tau. Here tau is the RC. Right, R and C. This is R is given, C is given. So what is the time constant? You can find R into C, that is 10 into 10 raised to power 3 into 47 into 10 raised to power minus 9 second. That is in nanofarad. Okay, we can calculate it, no problem. Now, you have to find the equation. That is a lengthy question. What is the equation? But once you will practice, it will become very easy for you. What is the final value when the capacitor will charge? When we are giving the infinite time, it will charge up to what? 5 volt. The final value is infinite, 5 volt. What is the initial value? 1.6 volt. Initial value is 1.6 volt. So you will get the equation first of all. During charging, 5 minus 1.6 e raised to power minus t by tau. Then what is the equation finally? 5 minus 3.4, check my calculation, e raised to power minus t by tau. Then my dear friend, at t equal to t on, this point is called t on. This is called t on, from this point to this point. When we are starting our equation, that is the 0 time and this is the t on time. Right, from this point to this point, it is the t off time. We are calculating the t on. During this, it will switch from 1.6 to 2.4. So exactly at t on, Vc will become 2.4 volt. Put here 2.4 volt is equal to, then finally I will give you the shortcut. E raised to power minus t by tau. Or in place of t, put the t on. Then from this 5 minus 2.4, it will become 2.6 divided by 3.4. Always remember t on will become tau log of. This should be positive. When the log will be positive, it should be greater than 1. So always remember that ratio will be 2.6. And that is called T on. Already we have the value of what? Tau. That is RC. You can find the T on from this. Now, on the similar calculation, what will be the T off? We are going to use the same equation, but the final value will change. What is the final value this time? During T of 0, because it will discharge towards 0. What is the supply here? 0. 0. Now VC will become 0 minus what is the initial value? That is the 2.4 volt. E raised to power minus T by tau. So during discharging, the equation will become 2.4 e raised to power minus T by tau. Tau will remain same. And exactly at T equal to T off, because we are starting from this procedure, this point, it is the time is 0. At this time, the time is T off. So exactly at T off, what is the value? 1.6. VC will become 1.6. Then 1.6 is equal to 2.4 e raised to power minus T off by tau. What is the T off? T off is tau log of, you can calculate 2.4 divided by 1.6. Tau log of 2.4 divided by 1.6. That will give you the T off. Okay. Then finally क्या बोल रहे हो आप? कहां पे आ गया? ये देखो, ये आ गया 2.4 divided by 1.6. अब finally calculate T on plus T off. This will become tau log of 3.4 divided by 2.6 plus 2.4 divided by 1.6. 2.4 divided by 1.6. This is called total time period. Once, and what is the tau? Already we have calculated the tau. This is the RC, 10 into 10 raised to power 3. Now you can calculate it. This is the 10 to the power 4, and this is the this will become 47 into 10 to the power minus 5 second. 10 to the power 4, that is the 47 into 10 raised to power minus 5 second. Now you can calculate it. The log means what? Multiplication. Multiply it and get the answer. When we are adding means what? Multiplication. So finally multiply and then get the answer for this question. But frequency is asked. If the frequency is asked, then directly we can calculate what? T is equal to 1 by F is equal to what? 1 by T. F is equal to 1 by T. Okay. So that is the case here. That is the case here. Okay. हाँ यही है. अब what is the beta here? Then yes, 1 plus beta upon 1 minus beta. Okay. But the threshold level is given here. Once the threshold level is given, so from this you can get the general formula. Okay, sorry, this is the 3.4, no? This is 3.4. 3.4 here. Okay guys, तो ये है पूरा, देखो इसका calculation. This is the part of the calculation. Please check everyone, what is the initial value, what is the final value, and then what is the gap, and so on. Now you can get the value here, why we are getting the 3.4, why we are getting the 2.6, and so on, to make general formula from this, all this theory, right? No doubt you are giving the log 1 plus beta upon 1 plus beta, but in that case, my dear, you have to know the idea about what R1, R2 and R3, R1 and R2, R1 and R2 relation, right? देखो कितना आ रहा है आंसर. What is the answer for this question? Now you can calculate it. Already answers are available. Everything is available. Don't worry about that. I will upload the PDF. That is the method. And that is the final answer. This is the T. Get the reciprocal of this. Okay. Give me 1 minute. I will provide you the answer also. क्या रहा आप बताइए जरा, कैलकुलेशन का आपका पार्ट है भाई, कैलकुलेशन कीजिए सब। दैट इज द क्वेश्चन ओके इन 2021। इलेक्ट्रिकल ब्रांच and answer is 3150 to 3170 hertz. You will get the answer 3150 to 3170 hertz, right? Okay, so please check. So देखिए what is the method here? If you have idea about the upper threshold and lower threshold level, upper threshold and what lower threshold level, so standard formula is what because when the standard formula is valid, when we are getting the upper threshold positive saturation and negative saturation value same. Vishwanath, you are giving na tau log of 1 plus beta upon 1 minus beta. So that is the formula. That formula is valid when we are having the positive saturation is 15, negative saturation is what minus 15. Then we are going to get that answer. Otherwise, that is the method. Okay. Now, next thing, with calculation, we can reduce our time. No need to write like this. You can directly reach up to this point. You can skip 1 or 2 steps here. When we are skipping 1 or 2 steps, directly you can write this equation. Always remember time should be positive. Suppose some students are writing 2.6 divided by 3.4. 2.6 divided by 3.4 will give you the negative value. Or all, remember one thing, time will be always positive. Now next question. Next one. Okay, to watch 2014 similar question. If students are not able to solve in in 2021 means already that is the simple problem. They are not going to उन्होंने क्या नहीं solve किया था, previous year question ही solve नहीं किया. Previous year question में तो ये already आया हुआ था. Now next one. अभी भी देखिए ये again this is a standard circuit. Circuit with an ideal operational amplifier is shown. Bode plot for the magnitude of the gain transfer function of the circuit is also provided. Omega frequency in radian per second. Here omega is the angular frequency in radian per second. The values of R and C, that is asked. 2022. Again it is a standard circuit. If R is connected here, C is connected here, it is nothing but low pass filter. Low pass filter. And for this low pass filter, what is the maximum gain? The maximum gain is at omega is equal to 0 when the capacitor will act as open circuit, and the maximum gain is 1 plus RF. This is the RF by R1. RF by R1. That is the maximum gain here. Okay. Means here the gain is given as 12. Right. So we can, but number of students will equate 1 plus R by 1 is equal to what? 12. And they will get the R is equal to what? 11. Right. They will get the R is equal to 11 kilo ohm. But there is no answer. That's why. Remember one thing, it is given in what? dB, 20 log of 10. This scale in what? dB. And this is in what? Log omega. That is a Bode plot. Okay. Then standard circuit. For this standard circuit, what is the formula here? The gain is given by, that is the function of omega is equal to maximum gain, because it is a low pass filter, 1 plus j with negative sign, because it is an inverting filter 180 this is a non-inverting integrator, that is maximum gain 1 plus omega by omega c, where omega c is the cutoff frequency. And what is the maximum gain? 1 plus RF by R1 divided by 1 plus j omega by omega c. That is the standard formula for this diagram. Now from the log table we can get what is the maximum gain? 12 dB. 20 log of A max is equal to 12. So what is the A max is equal to? A max is equal to NT log of log base to 10, na? 12 divided by 20. That is 6 by 10. That is the 0.6. 0.6. What is the NT log of 0.6? NT log of 0.6. 3.98. This is nearly equal to what? 4. So gain is 4. Now what is the maximum gain from the diagram? Equate 1 plus RF by R1 is equal to 4. So what is the RF R and what is the R1? 1 kilo ohm. 1 plus R by 1 is equal to 4. So what is the R is equal to 3 kilo ohm. R is equal to 3 kilo ohm. Right? So this is the 3 kilo ohm. This is the 20 log of that, and you can find the value. So 3 kilo ohm. So in which answer 3 kilo ohm? Only A or what? D. These are the not correct answer. Now second, we have to find the value of the capacitor. Omega. What is the omega for this diagram? Omega is given by 1 by RC. 1 by RC. You have to find the value of the C. Then C is equal to 1 by R omega. 1 by R omega. So what is the omega? It is given in log scale. This is the 3. Log of base to 10 omega is equal to 3. Means I take the anti-log, it will become 10 to the power 3. That is 1000 radian per second. Now put the value of R. R is given as 1 kilo ohm. This R, not this R. No, R is given as 1 kilo ohm. 10 to the power 3. Omega is 10 to the power 3, and that's why it is become 10 to the power minus 6 farad. Means 1 microfarad. So capacitor value is 1 microfarad. Answer A is the correct one. Remove this answer. A is the correct answer for this question. Okay. Yes. 1 plus, this is 1 plus RF by R1, no? 1 plus RF by R1. R by R. This is R divided by 1 kilo ohm. Already I have divided. RF by R1 already I have given. That is the 1 plus R divided by 1. That is equal to 4. So what is the R divided by 1? This is R. 4 minus 1. R will become 3 kilo ohm. Very simple. Because the value of RF is R. And what is the value of R1? 1 kilo ohm. And that's why the answer is in what? Kilo ohm. Answer is in what? Kilo ohm. Right? Series with CR. No. When we are considering that, remember, I am giving you the standard circuit. This is the RF, this is the R1, this is the R, this is the C. Okay? And this is the standard formula. Remember, always remember. For this particular circuit, this is the RF, this is the R1, this is R, and this is C. Here we are giving the input, sinusoidal input. This is grounded. So what is the maximum gain? Always remember, this is given by 1 plus RF by R1. This one and that one. No doubt in this question, these R and these two are same, but this is the standard circuit. And what is the omega C? Cutoff frequency is given by 1 by RC. This R and this C. Okay. If it is FC is asked, 1 by 2 pi RC in hertz. And that is in radian per second. Right? Now, next question. So, go through the last 10 years previous year question, electrical and electronics branch. How many times question from low pass filter? Then you will get the idea what about the topic. Right? That is important, but they will change the nature. For example, in this question, they already added what Bode plot and so on. So, they will change like this. Otherwise, that is a standard circuit. Again, diode, question on diode. Okay. Now, a circuit and the characteristics of the diode are shown. This is the circuit, diode are shown. The ratio of the minimum to maximum is small signal voltage gain. Small signal voltage gain, dV out by d in. So, वैसे भी gain, what is the definition of the gain? Change in the output because of change in the input. That is called small signal voltage gain. Now, here the diode, again in the same year 2022 characteristics of the diode is given. This time it is what? 0.7 volt. 0.7 volt means when the diode is forward bias, there will be the drop of what? 0.7 volt. Or when the diode is reverse bias, it will act as what? Open circuit, because the current is what? 0. This is given, current is 0. This is the characteristics of practical diode. It is a silicon diode, right? Now, we are having the two cases. When there is a diode, there will be always two cases. First case is what? Diode on. Second case is what? Diode off. Diode on or what? Diode off. We have to find the gain. Okay. Let first case, when the diode is off, then what will be the gain? Okay. So we will check the gain. When the diode is on, diode is off. I am considering the first case off. Then this is simple 2 kilo ohm. This 2 kilo ohm and this 2 kilo ohm are in series. Right. This point, like this is the point A, this is the point B. Between A and B, we are having the 2 kilo ohm, 2 kilo ohm series, and that diode is off, and we are getting the output from A and B. So this is A, this is B, and that is the output. Okay. Now, this is the V in. First of all, what is the V out? According to voltage divide rule, 2 plus 2, 4 divided by total resistance 4 plus 2, 6 into V in. This will become 2 by 3 V in. Okay. Now you want the small signal change. So when we want the small signal change, then simply differentiate it with respect to V in. It will become 2 by 3 because the differentiation of V in will become 1, and that is the gain. 2 by 3. When the diode is off, the gain is what? 2 by 3. Now, in second case, when the diode is on, now, remember one thing, when the diode is on, this will not, this is not short circuit. It will act as what? Voltage what? 0.7 volt. 0.7 volt. Then, you have to use the concept of network here. This is the diagram. Here we are taking the output between point A and point B, but this time this diode is on. So what is the drop across the diode? 0.7 volt. 0.7 volt, and that is R. This is R. This is R. This is V in. Okay. How we are going to find the V out by V in, or V out in terms of what? V in. V out in terms of V in means what? The voltage at this point with respect to ground is V out. Now we are having the voltage 0.7 between, let this is the another node, let this is the Vx. So we can apply the super nodal analysis. We are going to apply what? Super nodal analysis. Not, it will not act as short circuit because it is a practical diode. We are going to apply the super nodal analysis. So what is the V0 minus Vx? V0 minus Vx is 0.7 volt. That is the first equation. Then apply the super nodal because that is connected in parallel. You can remove this resistor. When resistor in parallel with the battery, you can remove that resistor. So V0 minus Vi by R. I am applying the super nodal. So ये हो गया आपका, I am writing the KCL by R plus, now at this point write down the KCL Vx by R is equal to what? 0. So R cancel out. Now V0 minus Vi plus Vx. What is the Vx here? Vx will become V0 minus 0.7 from this point. V0 minus 0.7. This is the Vx, V0 minus 0.7 from equation number 1. It will become 0. Now, this is 2V0 minus is equal to, this is the 2V0 is equal to Vi minus Vi plus 0.7. Vi plus 0.7. That is the equation. So what is the V0 here? V0 will become Vi by 2 from this, Vi by 2 plus 0.7 by 2. Okay. That is under DC condition. But what is the gain? The change in output because of change in input. So differentiate it. differentiate with respect to Vi. It will become dV naught by dVi. That is, this constant will become 0 and this will become 1 by 2. Because what is the differentiation of Vi? 1 by 2. Now, this is the gain in second case. And that is the gain in first case. So, 2 by 3 is 0.667. It is greater than what? 1 by 2. And what is asked in the question? Ratio of minimum to maximum. Minimum to maximum. So, when minimum to maximum means dV naught by dVi minimum, dV naught by dVi maximum. So, what is the minimum? 1 by 2. What is the maximum? 2 by 3. So, it will become 3 by 4. What is the 3 by 4? 0.75. 0.75 is the answer for this question. Okay. So, in exam hall, why you have to use scribble pad effectively, draw the diagram, neat and clean diagram, try to avoid the silly mistakes. You have to maintain what? Accuracy. So, that is the case. At the same time, we are applying what? Supernodal analysis. You can apply any other method to find the voltage at this point. Okay. Or you can find the relation between V out by V in. I am using the supernodal here. You can apply any other method, right? You can directly consider one current here, I, let the same current will pass here, I, write down the KVL, you will get the I. Now finally you can find the value of V0 in terms of what? I. Again you are going to get the same answer for this question. Okay, so that is the, any doubt then you can ask. Any doubt then you can ask here. Don't try to mug up the question. ये हो गया. This is in 2022. Next question. Now, question on MOSFET in electronics. Question on MOSFET. What is the E and B? I'm giving you my Telegram channel. Please everyone like the session and join that Telegram channel. That is Electronics by Sanjay Rathi. If you want the PDF. So what is the problem? One student write there that PDF quality of PDF is not good. What is the problem? Okay. So that is okay. It is blur, Ravi Shankar. It is readable or not? Otherwise, I have to work on that. Not that much clear. Okay. I will check just after the class. So that is my Telegram channel link. Please consider it. Okay, I will upload that. Don't worry. Then, now, this type of question. Consider the circuit shown with an ideal long channel N MOSFET. Okay, watch the diagram. It is N MOSFET. No need to read all this point. Substrate is connected to the source. Normally, we are connecting the body terminal to the source terminal. That is a general term. I am giving you why we are connecting. For example, always remember, avoid this point. Right? In exam hall, always consider this point. This is a very basic thing. This is SiO2 layer. This is the source terminal. It is connected to what? Body terminal. And that is called substrate. Body terminal is also called substrate terminal. This is the P-type substrate. This is N positive. This is N positive. And here we are connecting positive value, VDS. Here we are giving the positive value, VGS. Now, this is the source terminal. Normally, we are making it ground. But these two are connected. Why we are connecting? Because so that this junction will be what? Reverse bias. This is called source body junction. This is called drain body junction. When already it is short circuited, this junction is reverse bias. Because it is connected to positive value, that this junction is also reverse bias. This junction is also reverse bias. So in every question they will write the enhancement mode, substrate is connected to the source. Okay. The transistor is appropriately biased in the saturation region. Already it is in saturation region, and that's why the VDD and the value of VGG is not given. So no need to check. Already it is in saturation region. such that it acts as a linear amplifier. When we are talking about the linear amplifier, means the signal, applied signal, the AC signal is very, very small. This signal is very small. So maintain the linearity. And that's why it is a small signal analysis. Vi is the small signal AC input voltage. VA and VB represent the small signal voltages, VA and VB. This is the, at this point, we are getting VA, at this point, we are getting the VB. At the nodes, respectively, the values of VA by VB is. The values of VA by VB is. Now, one word is used here, small signal. When one word is used here, small signal, means what? Student will draw the small signal model and they will try to solve this question. But remember one thing, what is with this diagram we can solve this question. With the help of this diagram we can solve this question, very easy. No need to draw the small signal model. But basic concept of gain. First of all, during AC analysis, what about all the DC sources? Tends to 0. To make it 0, VDD make it 0, VGG make it 0. Now, we are having the same current, right, from, for example, I am writing the I0. So what is the IG here? 0. Same current will pass from this point to this point, like this voltage is VA. Same current. Because this current is 0, I0 will pass from this point to this point. Now, this is the voltage VB. Now, we can write the VA is equal to what? From this point to this point, I0 into 4. 4 into I0. Now, what is the VB? From 0 to this, so we can write 0 minus VB. 0 minus VB is equal to 2 into I0. So what is the VB is equal to minus 2 I0, because current flows from higher potential to lower potential. So this is the direction, this is in opposite direction. Or we can directly say what is the current in the negative direction, minus I0. So you can write minus 2 I0. So VB will become minus 2 I0, that will become 4 I0. So what is the ratio between VA and VB? What is asked in the question? VA by VB, minus 2. Very simple. Divide these two equations, it will become minus 2. No need to draw a small signal. Okay guys, this is clear. This point is clear. If suppose you want to draw the small signal, again no problem. You want to draw the small signal, remember one thing, R0 is not given. Okay, right? A small signal AC input, V and VB respectively, small signal voltage at node A and B, then what is the value? Okay, then you can draw a small signal like this. Let this is the GMVGS. Okay, that is RD, drain resistance. This is the gate terminal, this is the source terminal. From source to ground 2 kilo ohm is connected. That is the ground. And from drain to ground 4 kilo ohm is connected. This is the drain. Drain to ground 4 kilo ohm is connected. This voltage is VA. This is 4 kilo ohm. 2 kilo ohm. And this voltage is VB. This is the VB. At this point it is a VB. From this point to this point, this is VI is connected. And this voltage is called VGS. My dear, remember one thing, that this is the drain current ID. Same current will pass, it will divide, again the same current will pass through this. What is the current here? ID minus GM VGS. Now my dear friend, the same ID will flow like this from this point to this point, and it is divided again ID. So what is the VA? Now this time VA will become minus ID into 4. And VB will become ID into 2 from the small signal model. So what is the VA by VB? Minus 4 by 2. Again you will get the same answer, minus 2. Minus 2. And that is the with the help of a small signal model. Very good evening Karthik, how are you? Right? So I think both the methods are clear to you. Okay, both the methods are clear. By using the small signal model or by using directly, you can write the answer for this particular question. Okay. ID minus GM, my dear Murli, I am simply applying the KCL here. Okay, no problem. What is the current at this node? ID. What is the current here? GMVGS. So what will be the current here? ID minus GMVGS. The current through this RD is ID because the current at this node I am applying the KCL. What is the incoming current? ID. So what is the outgoing current? GMVGS. So what is the outgoing current here? ID minus GMVGS. Now you can write, if you want to find the gain, I will solve one question on that. I will solve one question on this. Okay. Because we have number of questions. Same type of question on a small signal model. Now you can write the KVL at this loop. Because we can't write the KVL through current source. And that's why we are dividing. Okay. Mega mock question. Sir, some doubts are there in EDC problem. Will you take? Yes. I'm going to take session on that. EDC and analog network. I think I have to cover 3 or 4 subjects. EDC, analog, digital and so on. Okay. I will take that session. Okay. This is clear, I think. So in this way we can find. Now if it is asked, remember this is a standard circuit. Next time they will ask what is the VA upon VI. From this again you can get the V upon VI. What is the VB upon VI? Again you will get the VB upon VI. Model will remain same. Model will remain same. Okay. Next question. Okay. Now this is from the electronics branch in 2022. Again I have 2 or more questions. Tomorrow we will solve in second part. But now electrical branch. So what is the nature of the question in electrical branch from analog? Okay. For an ideal MOSFET biased in saturation, the magnitude of the small signal current gain for the common drain amplifier. This is I think this is a 1 marks question, but again it is a very conceptual question. Same. For an ideal MOSFET biased in saturation, the magnitude of the small signal, not asking about the voltage, small signal current gain for the common drain amplifier. What is the common drain? Common drain means we are taking the output from the source. This is the output. Here we are connecting the RS register. Here it is a gate. Here we are giving the input. Here we are getting the output and this is the VDD. This is called common drain. Right? Drain terminal is common. We are getting the output from the source. We are giving input to the gate and that's why it is called common drain. Now here this point is connected to ground I0 and this is the input current II. So what is the current gain? I0 upon II. But tell me, if it is an ideal MOSFET, what about the current in MOSFET? Current in MOSFET. So current in the MOSFET is what? 0. Current, because the input resistance is what? Infinite. Nothing is given. If the current II is 0, so what will be the gain? Infinite. Gain will become infinite. So current gain is simply infinity for common drain. And what is the another name of common drain? What is the another name of common drain? Give me the answer in comments box. Common drain amplifier is also called, and it is similar to common collector. It is similar to common collector. It is analogous to voltage follower. So what is the name of this circuit? Common collector. Analogous to common collector, analogous to voltage follower. So what is the another name of this common drain? Give me the answer in comments box. Next time you will get MSQ on that. Okay. Okay. So the answer is what? Infinite. Answer is infinite. Common, similar to common collector, similar to voltage for. Dekho, what is the another name of common collector? Buffer. Okay. What is the another name of common collector? Emitter follower. This is called source follower because voltage gain is 1. Source will follow the input. Source follower. In voltage follower, voltage gain is 1. Current gain is very high. In common collector, current gain is very high. In voltage follower, current gain is high. or in this case again the current gain is what? Infinite. Ideal condition infinite. Okay, but what about the voltage gain? In all the cases it is 1. This is act as what? Buffer. It is a source follower. What is the another name? Source follower, because we are taking the output from the source. Okay, then the steady state output of the circuit shown below will be steady state output, right? And that is the diagram. Again, in electrical branch, 0.1 volt is given, R1 is given, capacitor is given, R1 here, it is connected here, R1. Okay. Now what is the steady state output? Now instrumentation, how many students from instrumentation branch? Instrumentation branch. Now if the steady state output is asked, what about this voltage? This is the DC voltage. 0.1 volt is DC. So for any DC voltage under steady state condition, capacitor act as what? Open circuit. Very simple. In this diagram, when once the capacitor act as open circuit, then this is open, there will be no current, means there is no negative feedback. This point is open now. This is R1. This is 0.1 volt. Now at this point, because there is no current, why there is no current? Because what is the input resistance of the operational amplifier? Infinite. So I2 and I1 is 0. Current enter into the operational amplifier is 0 because input resistance is infinite. What will be the drop across this R1? 0. Capacitor acts as open circuit. So voltage at the negative terminal is 0.1 volt. And this is the positive terminal voltage. So VI. Now when the negative terminal voltage is greater than the positive terminal voltage, yes, Payas Kumari, you are giving the answer that infinity. Yes, input resistance is infinite. When the negative terminal voltage is greater than positive terminal, what is the gain? Ideal operational amplifier, it is written. Nothing is written, means ideal op amp. Very high gain. Normally it is a 10 to the power 6 or infinite. When the negative is greater than positive terminal voltage, output will be minus V set. Or if the positive terminal voltage is greater than negative terminal, output will be plus V set. Right? Minus V set or plus V set. Because there is no negative feedback, this acts as open circuit, and that's why minus V. What is the supply here? Minus V set is what? Here minus VEE is given. Okay, no problem. Here VDD is given. This is the minus VEE. Saturate to what? Minus VEE. Saturate to minus VEE. Right. Here simple sa question. Otherwise, what is the name of this circuit? It is a integrator. It is what? Integrator. This is the standard circuit of integrator. If suppose we are giving the square wave, it will convert it into what? Triangular wave. But remember one thing, we have to avoid what? Saturation. Positive saturation and what? Negative saturation. We have to adjust the timing according to that. Next one. Next question. For the circuit shown below with ideal diodes, the output will be. Always there will be a question on what? That is the answer is what? B. To saturate to VE minus VE. Dekho. Last to last time this type of circuit, na? This type, I think this type of circuit. Cross connection and so on. Resistor is connected there. One diode is connected like this. And one diode is connected like this. And that is asked. Here we are, VI is connected. Here we are getting the V0. This is nothing but half wave rectifier. Go like this. P to N. P to N. This was the question. Right? Now this time simple question, direct. So when we are having the positive, both the diodes are simultaneously on. right? For positive half, both the diodes are on, and for negative half, both the diodes are off. So during positive half, what will be the output? One minute. Okay, no diagram, no problem. Ideal diode, during positive half, both the diodes are on. The output is exactly replica of the input, right? But during negative half, both the diodes are off. What will be the output? 0. We are getting the output equal to input when during positive half. So this is the case. So V out is equal to V in for V in greater than 0. So electrical branch, tell me what is the nature of the question. Very basic question, right? And try to solve the question from 2014, 15 or in 2012, 13, 14 and so on. Level of question is level of question was very high. But this time normal question in electrical branch, right? But if suppose it is MSQ, then what will be the question, my dear student? Now I am going to frame one question on this. This is a standard circuit for half wave rectifier. This is the standard circuit for a half wave rectifier. This is the V naught. Here we are giving the V. Now in this case, again we are connecting one diode in series. This is the circuit. Here we are connecting the V in. Here we are connecting the V out. Okay. Now in this case, if I am applying the 10 sin omega t, in this case when I am applying the 10 sin omega t, then PIV, peak inverse voltage, will be Vm, that is equal to what? 10 volt. PIV means maximum voltage appearing across the diode when the diode is reverse bias. But in this case, when I am finding the PIV, both the diodes are off. Both the diodes are off when we are applying the negative voltage, negative minus, that is the 10 volt. When it is a maximum, both the diodes are off. So what is the PIV of individual diode? PIV of the diode will become, this is plus minus, this is plus minus, 5 volt, 5 volt, only half Vm by 2. Vm by 2. So why we are connecting the two diodes? We are connecting the two diodes in series to first purpose is to reduce what? Peak inverse voltage. Peak inverse voltage. Learn this, Ravi Shankar Kirti. This time the EC will get easy. The last time, don't anticipate this type of things. Okay. अब यार एक बात बताओ, it may be hard or it may be easy. If it will be hard, then hard for everyone. If it is easy, then easy for every other students, right? Okay, don't worry. And you have to give your best effort. Nothing hard है चाहे easy है, previous year के हिसाब से हम नहीं बता सकते कि क्या आएगा. ओके कई बार लगता है ना कि अरे इस साल तो बहुत बारिश हो गई, अब अगले साल होगी कि नहीं होगी, पता चला अगले साल और ज़्यादा हो गई. ठीक है, कुछ बोल नहीं सकते. अपने आप को तैयार रखिए, आपकी प्रैक्टिस ज़बरदस्त होनी चाहिए. ओके, तो दैट इज आंसर. नाउ द आउटपुट, ये देखो, दिस इज द क्वेश्चन. दिस इज अ क्वेश्चन इन व्हाट? इलेक्ट्रिकल ब्रांच. द लेवल ऑफ क्वेश्चन इज टू हाई, राइट? नाउ the output impedance of a non-ideal operational amplifier. This is a operational amplifier is connected. It is a voltage follower. If it is ideal, then it is a voltage follower. We can simply say it is a voltage follower circuit. The variation in the magnitude of Z out with increasing frequency in the circuit shown below is the best represented by. Best represented by means what? Ashok, what is the answer for this question? Vyas Kumar, you are giving the C, right? This is the right. So ये है C. Okay, check करते जरा. Now, here, what is the feedback mechanism? Here we are simply using the concept of feedback. In a voltage follower or in non-inverting op-amp, remember, in non-inverting operational amplifier, voltage follower is also a non-inverting operational amplifier. The feedback mechanism is voltage series feedback. Feedback mechanism is what? Voltage series feedback. When the feedback mechanism is voltage series feedback, there is a feedback. What is the feedback factor? Beta. Beta is what? R1 upon R1 plus RF. If it is a non-inverting op-amp, then non-inverting op-amp means this one. Here we are giving the Vin. This is RF, this is R1. But in this case, RF is 0. When the RF is 0, R1 by R1 cancel out and beta is what? 1. For voltage follower, the beta will become 1. For non-inverting operational amplifier, beta will become R1 upon R1 plus RF. Now, because of this feedback mechanism, what is the input impedance? Input impedance increases 1 plus AV beta into what? Ri. Into what? Ri. So, what is this? Remember, Ri is the, or Zi is the input impedance of the open loop operational amplifier. Or this Zin is the resistance seen by this impedance after feedback. We can say this is with feedback and this is without feedback. It may be Zi or it may be Zin. So that is the phase 1 plus AV beta. Similarly, what is the Z out? Z out with feedback is given by Z0 upon 1 plus AV beta. What is the beta? Beta is a beta is 1. Already we have proved for this diagram beta is 1. And AV is normally greater than 1. We can neglect, but you can write Z0 upon 1 plus AV. Okay, no problem. Because beta is 1. Now, what about the operational amplifier? It acts as what? A direct coupled amplifier. One for direct coupled amplifier. For operational amplifier, what is the characteristics here? It acts as what? Low pass filter, like this. This is the characteristics of the operational amplifier. Watch this. This type of characteristics. For direct coupled, that is the case. Okay. And this is called cutoff frequency. Now, so what is the gain here? A equal to low pass filter. It is a function of omega. A maximum. This is the A maximum. Divided by 1 plus J. Already I have given you the standard formula for low pass filter. Omega by omega C. Omega by omega C. So what is the magnitude? It will become A maximum upon root over 1 plus omega by omega C the whole square. Omega by omega C the whole square. But remember one thing. This is the low pass filter. But what about the Z0? It is in denominator. It is in what? Denominator. Okay. What will happen? Exactly when the omega is equal to 0, the gain is maximum. When the gain is maximum, impedance will be minimum. So where is the gain is the maximum, impedance is minimum? Here. Initially, so when the gain is right, it depends upon the frequency. When the frequency is very low, the gain is maximum. That's why impedance is minimum. When we are increasing the frequency, the gain will reduce. So what about the impedance? Impedance will increase and finally it will saturate. It will reach up to what? Maximum level, and then it will become constant. Okay, that is the case. Which answer? In a inverting operational amplifier, the feedback mechanism is voltage shunt. In non-inverting operational amplifier, feedback mechanism is what? Right, feedback mechanism is voltage series feedback. In non-inverting, voltage series feedback. Okay, that is the answer. For the log scale, linearly it will not increase, right? Because ultimately at high frequency it will become a constant level. It will reach up to what? A maximum level, and then it will saturate. Because that is the formula. Remember one thing. This is the standard formula for operational amplifier, open loop operational amplifier. Low pass filter standard circuit, simple. Low pass filter means what? This is the R. This is C. It is a passive filter. For passive filter, what is the gain? V naught by Vi. You can calculate. V naught by Vi is equal to impedance Z2 upon Z1 plus Z2. So what is the Z2? 1 by SC upon R plus 1 by SC. Then it will become 1 upon 1 plus SCR. What is S? 1 upon 1 plus J omega RC. Now you are taking the omega C, that is the cutoff frequency, is equal to 1 by RC. You can replace RC by 1 by omega C. So what is the standard formula? Gain will become 1 upon 1 plus J by omega C, where omega C is the 1 by RC. So that is this is for passive filter. This is for what? Passive filter. When it is an active filter, then the gain will increase. So what will be the gain? Maximum. जो भी maximum possible gain है upon 1 plus J by omega C. For passive filter, what is the maximum gain possible? 1. And that's why we are writing 1 upon. If it is active filter, what is the maximum gain possible? When we are going to get the maximum gain? When we are putting omega is equal to 0. So omega is equal to what? 0. In the operational amplifier. Na? So yes, in operational amplifier, in a case of open loop operational amplifier, tell me, what is this? Open loop operational amplifier, we are having the gain that we are saying that it is a 10 to the power 6. Okay. But at this point, no doubt the 10 to the power 6. But when we are increasing the frequency, because of internal capacitance, what are the internal diffusion, transition, wiring, stray capacitance, at the high frequency, the gain will reduce. And the gain bandwidth product is what? Constant. Bandwidth is not infinite. Bandwidth is limited. This is the bandwidth. And that because it is a direct coupled, and that's why we are getting this type of characteristics. You have to revise all these things. What is the direct coupled amplifier, and what about the RC coupled amplifier? So this is the characteristics frequency response curve for the gain versus frequency for open loop operational amplifier. At the high frequency, this is called cutoff frequency FH, and that FH is nothing but bandwidth or omega H. Not clear? And this is the standard formula for low pass. It behaves like what? Low pass filter. So this is the standard formula for low pass filter. That's why we are getting. Okay, next question. If you want this type of session, please write your comments. Write your comments in what? My Telegram channel. Okay. And then after completing the previous year question, we are going to arrange what? Marathon session. So subscribe our channel. Give me topics. These topics are difficult, or these topics, so we want lecture on these topics. Definitely I will cover those topics, okay, in my marathon session on analog, on EDC, okay. So that we will cover all these topics. So please get the idea which type of questions in previous year question. Okay, we have no idea about this concept. What is the voltage series feedback, voltage shunt feedback? In electrical branch, we are using the concept of this so that we are getting the answer. Okay. The next one, the current gain I out by I in the circuit with an ideal current amplifier given below, right? Simple current gain. This time current gain is asked. So what is the voltage? Let this the voltage at this point is V0. What is the virtual short concept? Because the gain is infinite. So what is the voltage at this point? 0. So it is a very simple question on operational amplifier. Vp is equal to Vn is equal to what? 0. What is the current enter into the operational amplifier? 0. Why? Input resistance is infinite. So if this is the IN, so what is the path of the IN? This is the path of the IN. IN flow like this. And that is the direction given. And what is the I out? Let the voltage at this point is V0. Now you can write I out is equal to V out by ZC. Yes, ZCC. Right? Okay. Or in a simple, what is the ZCC? 1 by SCC. In Laplace, we write 1 by SCC. And that's why the I out will become SCC into V. SCC upon V. Okay. Similarly, the voltage at this point is V0. Voltage at this point is 0. So you can write I in is equal to what? I in is equal to V out minus V0. V out minus 0 upon the impedance because of this. ZCF. V naught upon 1 by SCF. It will become SCF into V naught. Very simple. Now, what is the I out by I in? I out by I in will become V naught cancel, S cancel, CC upon CF. CC upon CF. This is not negative. This is positive value. CC upon CF. Not negative. What is the direction of the current? No doubt it is converted to inverting terminal. But what is the direction of the current? I in. Right? It is not inside. It is outside. That's why. Same current we are getting. Same here. So relation is given I out by I in. We are not writing the KCL. No? Okay. Or now we are not saying that I out is equal to what I in. I out is not equal to I in. Okay. Simple. This is the method. Simple. Write the V naught minus 0 by this impedance, V naught minus this, that impedance, and directly you can find the value. Okay then. Common factor cancel out and you will get the idea. Now, that is the diagram. For the circuit, ये ना एक इसमें ना कई बार there is some problem with this question. Okay, no problem. I have given a similar question, but this is a question on a differential amplifier actually. This is the question on differential amplifier. But sometimes, right, if there is some problem, then directly go for that. If they will give you marks to all, or otherwise, what is the tentative answer for that? Choose the right, choose the best answer, not the correct, but best answer. Okay. So what is the problem with this question? In electrical branch, in electronics branch in 2021. Okay. Then watch this. What is written here? For the circuit with an ideal op-amp shown in the figure, V reference is fixed. This is the V reference, this is fixed. When this is fixed means voltage across these two resistors are fixed. When this is fixed means voltage at this point is fixed. Positive terminal voltage is fixed. If V out is 1 volt, for V in is equal to 0.1 volt, and V out is 6 volt, for V in is equal to 1 volt. So we are having the two different values of V in. First 0.1 volt, second 1 volt. We can't assume anything that is given in the question. And in second case, V out is 6 volt. In first case, V out is 1 volt. Always write like this. This is given. V in, V out 1 volt. Jab V into in second case, it is the 1 volt. It is increases. So V naught increases up to what? 6 volt. Increases up to what? 6 volt. Just I am giving you the concept. I have just how to solve this particular question. No problem. Right. Then remember one thing here. This is a standard circuit of differential amplifier. Differential amplifier. Now, this is the differential. What is the voltage at this point? You can find R2 upon what is the VP? VP will become R2 upon R1 plus R2 into what? V reference. Now, this is the V reference. So, R2 upon R1 plus R2 into V reference. That is the voltage at this point. When we are applying the superposition theorem, first of all, make the V in is equal to 0. When we are making the V in is equal to 0, and at this point we are getting the VP. This is RF, this is R1. Now because of this, the V naught 1 will become 1 plus RF by R1 into VP. And what is the VP here? R2 by R1 plus R2 into V reference. Okay, that is the standard formula. Into R2 upon R1 plus R2 into what? V reference. This is the voltage because of positive terminal voltage. Now, what is the voltage because of the negative terminal voltage? Okay, because of negative terminal voltage, let V reference is 0. When we are making the V reference 0, Vp will become 0. This is connected to ground. This V reference 0 means Vp will become 0. This point is connected to ground, and here we are considering the Vin. So what is the output voltage? V02. This will become V02. We are just applying the superposition theorem. So minus Rf by Rn into Vin. Minus Rf by Rn into Vin. Okay. Now what is the total voltage then? The total voltage will become V01 plus V02. Remember formula. For non-inverting terminal, what is the gain? 1 plus Rf by R1. And what is the Vp? According to voltage divide rule, R2 by R1 plus R2 into voltage at non-inverting terminal, that is the V reference. In exam hall, directly write this equation. This is a standard circuit. Then minus, what is the R2? Rf by R1 into what? Vin. Rf by R1 into Vin. Now, this will remain constant. In a given question, this will remain constant. You can choose it any value. In the first case, the V01 is equal to, let this is a constant, A, you can choose A. Then this will become Rf by R1. In first case, what is the Vin? 0.1. First case, Vin is 0.1. And what is the V01? 1 volt. That is the first case. When Vin is 1.1, this is the 1 volt. Directly you can write it. 1 volt. In the second case, this term will remain same, minus Rf by R1. You are increasing it to 1 volt and this output is increased what? 6 volt. And that is the mistake here. If suppose we are increasing the negative terminal voltage, how the voltage will increase? It should decrease. It should what? Decrease. When we are increasing this is the constant. We are increasing the negative terminal voltage, so definitely when it is 10 times increases, so what about the output? It should decrease. So there is some problem in this question. Okay, no problem. But if suppose we are considering it, then from these two equations, when we want to find, we are having the two equations, A is common. You can subtract 2 minus 1. If suppose I am doing the 2 minus 1, it will become 6 minus 1, here we are getting the 5, here this minus this, you are going to get minus 0.9 Rf by R1, and here you will get what? 5. 6 minus 1, that is 5. So what is the Rf by R1? Rf by R1 will become minus 5 by 0.9. And what is the asked here? Rf by Rin, that is asked here. Simply bataiye what is the answer? Rf by Rin, it will become minus 5 by 0.9. $5.55. Right? Without any assumptions, without doing any modification in the question. So if it is asked only the without sign it is asked, then it means only magnitude is asked. We can directly write 5.555 for this particular question. But again, this diagram is very important. Get the command over differential amplifier, CMRR, AD, AC, right? What is the ideal value? What are the practical values and so on. Okay, this is important diagram. Next one. Please, new students, please write this formula 5 to 6 times. Don't try to mug up. We are applying the superposition theorem and then write this formula 5 to 6 times. You will get the command over this. Okay. This is a positive terminal voltage. That is the negative terminal voltage. Now, a circuit with an ideal op-amp is shown in the figure. Right. This was the question in 2021. Okay. Circuit with an ideal operational amplifier is shown in the figure. A pulse Vin of the 20 millisecond duration is applied to the input. The capacitors are initially uncharged. The output voltage V out of this circuit at t equal to 0 plus is. just exactly at t equal to 0 plus, what will be the output voltage? T equal to 0 plus means we are applying the pulse here. We are applying, suddenly at this point we are applying the 5 volt. Now what is the nature of the capacitor? Try to understand what is the nature of the capacitor. Initially if it is uncharged, then capacitor, remember, it does not allow sudden change of what? Voltage. तो ये जो क्वेश्चन है मैं आप लोगों को कल अभी हमारा सेशन बहुत लंबा चलने वाला है, राइट? तो मैं ये चाहूंगा कि आप इसको बनाओ. दिस इज द असाइनमेंट. टुमारो आई हैव पार्ट 2 एनालॉग. Continue. I am going to solve number of questions. Part 2 tomorrow at 6 p.m. To get the answer for this question, join that. Tomorrow 6 p.m. 6 to again 8:30 p.m. Okay, then try to solve this question. Remember one thing, but nature, I am giving you the nature of the capacitor. Capacitor does not allow sudden change of voltage. If it is initially uncharged, right, suddenly it will not going to charge here. Then what will be the answer for this particular question? At the same time, you have to use the property of what? Operational amplifier, because there is negative feedback. Negative feedback. If suppose I am using the ideal operational amplifier, right, pulse Vn is applied here, initially uncharged the output voltage, then there it is a 10 kilo ohm resistor is applied here. 10 kilo ohm resistor is here, right? Then what will be the current? If suppose we are assuming that the input resistance is infinite but nothing is given, circuit in ideal op amp is, it is written here, means what is the current enter into the operational amplifier? 0. Enter into the operational amplifier is what? 0. Okay, so try to solve this question. Ravi Shankar sir, you are not replying the groups regarding to the group. What is the other way to get the doubt clarification? You can post your doubt. You are in paid class, na? You are you in paid classes? If you are in paid classes, then definitely you can post your doubts. Within 24 hours, you will get the answer for your question. Okay. Right. Tell me. Now this is minus, this is plus. Consider the circuit with an ideal op amp shown in the figure, assuming Vin is very less than Vc and V reference is very less than Vc. Again, both the magnitude of this one and this one is very less as compared to the supplied voltage. V out equals to 0. Here, this type of questions, very simple one. When we are going to get the V out is equal to 0. When we want, like, okay, it is consider the ideal operational amplifier. If it is an ideal operational amplifier, there is a negative feedback. This is a negative feedback. That's why virtual short concept is valid. Voltage at this point is 0. And is saying that V out is also equal to 0. Let this is 0. Now, my dear friends, write down the KCL at this point. Finished. Voltage at this point, and you will get the relation between V in and what? V reference. 1 mark question. So try to solve this question. That this is 0. This is 0. Right, 0 minus V in, write down the KCL, upon R plus 0, this is the minus, actually this is given as minus, this is plus, 0 minus of minus V reference upon R. Right, what is the current enter into the operational amplifier? 0, because it is the ideal operational amplifier. What is the current here? 0. 0 minus 0 by RF is what? 0. No need to write it. That is 0. R will become 0. Minus V in plus V reference is equal to 0. So what is the relation between this? V in is equal to V reference. One line question. One line question. So in operational amplifier, remember one thing. At this terminal, what is the current enter into the operational amplifier? 0. But at this terminal, what is the current enter into this portion? It is not 0. Always remember. When we have to write the KCL at this point, we have to consider the current through this branch. Current through this branch. It is not 0. Okay. Next one. So that is the answer. Very easy question. Now, that is the question on what MOSFET. How to find the gain. How we can find the gain. We can get the Thevenin's equivalent for relation between V in and... we can find that. Yes. Now, in the circuit shown in the figure, the transistor M1 and M2 are operating in saturation. The channel length modulation coefficient of both the transistors are non-zero, right? Channel length coefficient is non-zero. The transconductance of the MOSFET M1 and M2 are GM1 and GM2 respectively. And internal resistance of the MOSFET M1 and M2 are R01 and R02. Means we have to consider the channel length modulation, and that's why we are getting the output resistance R01 and R02. Then, ignoring the body effect, the AC small signal gain of the circuit is. Electrical students, normally we are not getting this type of questions, but again the next question, watch that on the same model from electrical branch. तो चलिए बताते हैं जरा, what is the gain dV out by dV in of the circuit? dV out by dV in. एक बार भाई जरा जोश में आ जाओ, एक बार शेयर वगैरह कर लीजिए, और आप लोगों को अच्छा लग रहा है सेशन, आपको कुछ बातें समझ में आ रही है तो अपना रेस्पॉन्स भी कर दीजिए सबके सब. ओके, पता चला वन साइडेड क्लास जा रही है बस, तो आई वांट रिस्पॉन्स फ्रॉम योर साइड. जो भी आपको लगता है भेज दीजिए सब. ये सेशन लग रहा है आपको, हमारी जो ये सीरीज है आप लोगों के लिए यूजफुल है? क्वेश्चन बनाने से आपको समझ में आ रहा है इंपॉर्टेंट टॉपिक्स क्या है, क्वेश्चन को अप्रोच कैसे करना है, एंड सो ऑन. अब ये देखो ना कितना रिपीटेटिव नेचर है. सिमिलर टाइप ऑफ क्वेश्चंस इन लास्ट watch try to solve the last 10-year question, you will get the idea, right? Similar type of question. So देखिए what is the answer for this one, right? Now you have to draw the small signal model. First of all, what is the small signal model for MOSFET? Remember one thing, this is the GMVGS, and here RD is connected. RD is called R0, right? And this is the source terminal, this is the drain terminal, and this is the gate terminal. Okay, this is normally we are getting this. This is the VGS here. And what is the input impedance? Infinite. That is the small signal model for MOSFET, right? A small signal for model for MOSFET. That is the model. Then how we can solve it, right? So when the small signal model is considered, we are having the two MOSFET, M1 and M2. Let for this MOSFET the transconductance is GM2, for this MOSFET transconductance is GM1. This is the source terminal. This is the again the source terminal of the first and drain terminal of the second. So we have to connect the drain with the source. And in this case, the drain is connected to ground. Gate is also connected to ground. This is the first one. And this is the V in. V in means we are applying V into what? VGS, VG2, gate of 2 with respect to ground. If nothing is done, that is with respect to ground. Now, how we are going to make the proper diagram for this? Now, watch this diagram, right? Just I am changing the position here. When I am changing the position here, this will become GMVGS. 2. This is because 2, I am just changing the orientation. This is RD. Now, this terminal is source. This terminal is what? Drain. Watch this diagram. Change the orientation. This will lower will become drain and upper will become source. No problem. Right. Now, if this is the source, if I am writing the gate here, this will become VGS 2. This will become VGS 2 because it is a gate 2, source 2, drain 2. No problem, you can change. Now, during AC analysis, you have to make this all the DC sources is equal to 0, and that's why this point is connected to ground. And this RD is called R01. R01 here. Okay, RD is called R01 here. Then, what about this? Again, the source is connected here. Again, I am changing the orientation. Arrow towards source. This will become GM1 VGS1. In parallel, we are connecting R01. Okay. Remember, this is the source terminal S2. This is the drain terminal S1, sorry. D1. and this is the gate terminal G1, right? Now, and this, remember this voltage, this is important, VGS1, okay? Now, what about this gate? This gate is connected to ground. What about this drain? Drain is connected to ground. Drain and gate is connected to ground. D2 is connected to S1. D2, this is the D2 connected to what? S1. You can connect here. D2 is connected to S1. Now what about the VI? VI is connected to VG2 with respect to ground. So here you can connect VI with respect to ground. No problem. You can make like this. Okay. Okay, Fatam. Where is the output? From D2 terminal we are taking the output. Where is the D2? This is the D2 and S1. Here we are getting the output. Now you have to find the gain V0 by Vi. Right? Why we are reversing? What is the path here, my dear? Tell me. This is the drain terminal and that's my source. Reverse it. Resistor will remain same. Now this is the source terminal, this is the drain terminal, and that's why I am changing the direction. These two diagrams are similar. Are you getting my point? These two diagrams are similar. I am changing the node. This is source, this is drain. Now this is source, that is drain. Okay? That's why. Now, I think this model is clear. Now, once it is done, then you have to write what? KCL, and first of all, you have to find out what is the value of the VGS. Now, what is the voltage of this point with respect to ground? Vi. What is the voltage at this point with respect to ground? Because it is connected to 0, that is 0. So, what is the VGS2? Vi minus 0. So, VGS2 will become Vi. And that's why this GM2 VGS2 will become GM2 into Vi. Okay. Now, what is the VGS1? You have to find the VGS1 also. VGS1. If you want to find the VGS1, what about this VG1? It is connected to ground. Okay, no problem. Now, what is the voltage at this point? V0. So, VGS1 is nothing but VG1 minus VS1. What is the VG1? 0. What is the VS1? V0. Because VS1 is connected to V0. It will become minus V0. Now, this will become GM1 into what? V0. GM1 into V0. Now, diagram is over. Simply write what? KCL here. Write what? KCL here. What is the write the KCL at this point? When I will take next page for this. So, please. Now, diagram is over. Now, I am writing the KCL. Now, I am going to write the KCL. Okay. Oh, sorry. Not possible. Directly write KCL. Now, you can write problem. I want a space, so okay, I will create a space here. Vi is connected to ground. This is connected to ground. Now you can write. What is the outgoing current? GM to Vi. What is the outgoing current? V0 minus 0 by R01. R02, not R02, this is 2, remember this is 2 because it is the MOSFET number 2, this is the MOSFET number 1. V0 minus 0 by R01. R01. Now, what is the incoming current here? Minus GM1 VGS1. GM1, what is the VGS? Minus GM1 V0. But what is the V0? What is the VGS1? Minus V0. So, this is the, you have to write the minus here. You have to write the minus because what is the VGS1? Minus V0. When it is minus V0, minus, it will become plus because it is the incoming, but it is negative. That's why it will become plus. right? GM1 V naught. Okay, so already at the 4 points, this is the outgoing, this is the outgoing, this is the incoming, and that is the outgoing is equal to what? 0. Now from this you can find V naught upon Vi. When I am taking the V naught common, it will become V naught common GM1 plus 1 by R naught 2 plus 1 by R naught 1. Here it will become minus GM2 into Vi. What is the V naught by Vi? It will become minus GM2, and this is nothing but our conductance. So 3 conductance are connected in what? Parallel. GM1 parallel with 1 by R naught 2 parallel with 1 by R naught 1, and that is the answer for this question. That is the answer for this question. What is the answer? Which answer is correct? B. B is the correct one. So directly, if once it is for new student, once you will practice, you can within 20 seconds you can write the answer for all this question, my dear students. So but first of all, practice with what? Small signal model, similar type of question, minimum 3 times, similar type of questions. Sir, why one voltage is taken negative? Negative means why? Which voltage is taken as negative? Please watch now. What is the VGS1? The voltage at this point is 0. What is the voltage at this point? V0. So 0 minus V0. What is the VGS1? It will become minus V0. VGS1 minus VS1. So VG1 is 0. What is the VS1 minus V0? From the diagram, directly from the diagram, you will get the negative value. Draw the, please everyone, take your rough copy, draw the small signal model, connect it and get the idea. Then it will help you in exam hall. Okay. कोई भी ऐसे देखकर मत जाना भाई, जो भी चीजें आपको यहाँ पे जो भी लग रहा है, जो भी शॉर्टकट निकालना है, आप खुद ड्रॉ करो कॉपी में, राइट डाउन द KCL, गेट द आंसर, एक एक चीज एक्सप्लेन की हुई है, हाउ टू ड्रॉ द डायग्राम, कैसे ओरिएंटेशन चेंज करना है, क्या करना है, कौन सा पॉइंट ग्राउंड से कनेक्टेड है, ईच एंड एवरीथिंग इज मेंशन हियर. आई थिंक नाउ इट इज क्लियर, दिस पॉइंट इज क्लियर. ओके, देन next one, अब बताओ. And then again, if you want more detail about that, this diagram and so on, so we are going to take marathon session on that, where we will cover and what about the load. For example, in this diagram, this is a driver circuit because here we are giving the input. This will act as what? A load. This is nothing but a load. Its voltage, right? That is directly you can from this. What is the value of the VGS for this diagram? आप बोलेंगे sir, it is a NMOS, it is a PMOS actually. Why you are writing like that? Okay, don't worry about that. Whether it is a PMOS or NMOS, the answer, the model will remain same. Once when we are solving the small signal model, the model will remain same, the polarity will remain same, whether it is PMOS or NMOS. तो इसीलिए हमने परवाह नहीं की कि ये PMOS है तब भी आपका डायग्राम कैसे बन गया. लेकिन आप यहाँ पर देखिए, जब मैं इस वोल्टेज को निकाल रहा हूँ, तो दिस इज द polarity from which we will get the idea about this diagram, what is the value and so on, and then we can find the answer for this question. Okay, चलिए अब नेक्स्ट आते हैं, वो पूरा मैराथन में डिस्कस करेंगे. मैराथन में पूरा एक एक सेशन को एक एक डिटेल में लेंगे मॉसफेट को. बताइए व्हाट इज द आंसर फॉर दिस वन. क्वेश्चन ऑन जेनर डायोड. नाउ वी हैव 20 minutes. Question on Zener diode. Classes PDF will be available on what? My Telegram channel, that is Electronics by Sanjay Rathi. Just at after 11 PM I will upload because I have classes class from 9 to 11. Now tell me, in the circuit shown, read this question. Everyone read this question. 5 volt Zener diode is used to regulate the voltage across load R0. This R0 is the load. The input is an unregulated DC voltage with minimum value of 6 volt and maximum of 8 volt. So this is the range is what? 6 to 8. Minimum to maximum. The value of RS is 6 ohm. This is called series resistor. Only 6 ohm is given here. The Zener diode has a maximum rated power dissipation of 2.5 volt. So rating is given as 2.5 watt. Assuming the Zener diode to be ideal, the minimum value of R0 is, it is asked, right? For Zener diode, remember we have only two formula, right? Let this current is I, this is IZ, this is IL. We can write I is equal to IZ plus IL. What is the IZ is equal to I minus IL? One important formula. Second, from this formula, what is the IZ minimum? IZ minimum means when I is minimum and when IL is what? Maximum. This current should be greater than or equal to what? IZK. What is the IZK? Knee current. If in a particular question knee current is not given, choose ideal value, that is 0. So that is the first formula. And second formula is what? What is the IZ maximum? I maximum minus IL minimum. It should be greater, it should be less than or equal to IZ maximum, it should be less than or equal to IZ rating. Now what is the IZ rating? In this question, the IZ rating or maximum current is given by PZ rating divided by VZ. Because PZ rating is VZ into IZ rating. So 2.5 watt is given here. So 2.5 divided by what? What is the Zener diode voltage? 5 volt. You will get the IZ rating. 2.5 divided by 5. It is 0.5 ampere. Means 500 milliampere. That is the maximum current. Okay, through the Zener diode. And what is the minimum if IZK is not given? 0. Okay. Now, in this case, what is asked here? Minimum value of R0. Remember, when we are considering the IL maximum, so what is the IL maximum is equal to? This voltage is V0. This voltage is V0. V0 is nothing but VZ in regulated circuit. So IL maximum will become V0 upon what? RL minimum. You want the minimum value of R0, then we have to use this formula. Directly we are going to use this formula. IZ minimum is equal to I minimum minus IL maximum. Okay. Now, when we have to use this formula, then now what is the I minimum? I minimum means VI minimum minus VZ upon RS. VI minimum minus VS upon RS. IL maximum means V0 upon R0. It should be greater than or equal to 0 because IZK is not given in the question. So what is the minimum value of VI? That is given. What is the range of VI? 6 to 8. So it will become 6. What is the VZ? VZ is 5. You have, what is the RS? 6. Minus, what is the V0? V0 is nothing but VZ. 5. You have to find the R0. It should be greater than or equal to what? 0. Now, it will become 1 by 6 is equal to 5 R0. Greater than or equal to. So, what is the R0? R0 should be greater than or equal to 6 into 5. That is nothing but 30 ohm. What is the minimum value of R0? 30. What is asked here? Minimum value of R0. When it is equal to, it will become minimum value. 30 ohm. Direct formula. 30 ohm. Bilkul sahi. Right, Ashok, your answer is correct? Yes. So for Zener diode, always here, देखो in 2021, no doubt in 2022, no question from Zener diode, but it is again, it is a very important topic. Only two formula. For maximum rating of the Zener diode, it should be minimum Zener current or maximum rating of Zener diode means power rating. Power rating means from power rating we are getting the maximum Zener diode current through the Zener diode. This is IZ rating means maximum current through the Zener diode. Rated current, and this is the actual current in the circuit. This current should be less than what? Less than or equal to rating. If suppose it is greater than rating, then what about the Zener diode? The Zener diode may get damaged. Okay. So first of all, find the what is the maximum current through the Zener diode is possible, and what is the actual current in the circuit. So actual current, maximum current is I maximum minus IL minimum, right? Or ideal, under ideal condition you can under worst condition you can take IL minimum is equal to what? 0 also. IL minimum is equal to what? 0. In that case, if suppose it is 0, if R0 is not there, IL will become minimum. Then this complete maximum current will pass through the Zener diode. And this maximum current through the Zener diode, it should be less than what? Rating. It should be less than rating. What is the worst condition? If R0 is not given, IL will become 0. That is called the worst condition for this formula. Right. So, यहाँ पे पूछा नहीं है, तो we are using the second one. Now, signal generator having a source resistance of 50 ohm is set to generate a 1 kilohertz sine wave. Signal generator having a source resistance of 50 ohm is set to generate a 1 kilohertz sine wave. Open circuit terminal voltage is 10 volt peak to peak. Connecting a capacitor across the terminal reduces the voltage to 8 volt peak to peak. The value of this capacitor is. What is the value of this capacitor in electrical? तो ये देखो, ये जो क्वेश्चन है ना, ये नेटवर्क है. In network you will get the answer. That is the assignment for you, but just I am giving you the very simple hint for this. This is the RS. Here it is, the capacitor is connected, right? It is a 10 volt peak to peak is converted into what? 8 volt peak to peak, means that is decreased. So what is the value of the capacitor? Then you can find the value, or generate a 1 kilohertz sine wave. It is also given 1 kilohertz sine wave. Here the peak to peak value is 10 volt, but here we are getting the peak to peak value what? 8 volt. What is the value of the capacitor? Sorry, that is the question, but it is from network. Voltage division rule only. Voltage division rule. Now, this is the question on BJT in electrical engineering, right? Normally in electronics engineering, now the questions from what? MOSFET or what? Operational amplifier and so on. What is the answer? This is the PNP transistor. In the BJT circuit shown, the beta of the PNP transistor is 100. This is the PNP transistor. VB is equal to minus 0.7. Definitely it will be negative. So voltage across RC will be 5 volt. Voltage across this RC is given as 5 volt. What is the value of R2? You have to find the value of the R2. Okay. Now, in this question, remember, this current is emitter current. Why? Because this is emitter terminal. From this point to this point, this voltage is called VEB. VBE is given as minus 0.7. So what is the VEB? VBEB will become 0.7 volt. This is the 0.7 volt. This is the emitter current. This is the collector current. What is the direction? Outside. What is the direction of the base current? Outside. This is the PNP transistor. Base outside, collector outside. The relation will remain same. So what is the IC? You can directly find, because the voltage at this terminal is given. Collector voltage is given as 5 volt. In the question, voltage across the RC is 5 volt. So voltage across RC means here it is a 5 volt. Now you can find the IC. So IC is equal to 5 volt upon RC. What is the RC? 3.3 kilo ohm. So you will get this value. It is in kilo ohm because it is in milliampere. Once you will get the IC, you can find IB. What is the IC in active region? IC is equal to beta IB. So what is the IB is equal to IC upon beta. What is the beta given? 100. 5 divided by 3.3 into 100. That is the value of IB in milliampere. Then what is the value of IE? IE is equal to IC plus IB. I is equal to IC plus IB. So you have the IB, you have the IC, then you can find the I, that is the IC plus IB. Okay. Now IC plus IB. And now three currents are over. Okay. How we are going to find the R2? That is the purpose. That is our purpose. So how we are going to get the value of the R2? Remember, this is connected to ground. Now we have IE, IB or IC. Now what is the voltage at this terminal? The voltage at this terminal is 12 volt. This is the 12 volt. If you want to find the R2, then what is the current here? Let this current is I1. Let this current is I2. So I2 is nothing but IB plus I1. Once you will get the value of I2 and voltage at this terminal, then you can find the R2. That is the purpose. VB upon what? I2. Now we have to find the VB and then what? We have to find the R2. Now we can find the VB. We can find the VB when we are applying the KVL here. When we will apply KVL here. Where? In this portion. Write down the KVL. Voltage at this point is 12 volt. What is the voltage here? What is the VEB? 0.7 volt, and you can find the value of VB here. Once you know the VB, you can find the value of I1. 12 minus VB upon what? R1. I1 is known, IB is known, I1 plus IB, you will get the I2. Finished question. Right. चलिए निकालते हैं. देखो जरा. Then what is the value of VB? Write down the KVL from this point to this point. That will become 12 is equal to IE into 1.2 plus 0.7 volt. This is plus. VEB means plus. VB is negative but VEB is positive, plus VB. So what is the VB is equal to 12 minus 0.7 minus 1.2 times of IE. Give me the value. This is the value of the VB. Okay. IE means this one, IC plus IB. Okay. Okay. Then yes, you can also write IE is equal to 1 plus beta times of IB. Or you can also write 1 plus beta upon beta into what? IC, because IB is equal to IC upon beta. So that is another formula. Once you have the value of I, from this formula you can find the VB. Okay. Once you will get the value of VB, calculation is your part now. I1. You can find the I1. 12 minus VB upon 4.7. 12 minus VB upon 4.7. This will give you the I1. 12 minus VB upon 4.7. Once you will get the VB and I1, then IB plus I1 will give you I2. Now you have I1, you have IB. You will get the I2. Okay. VB upon I2. Find the value of I2. Finished. Around 17 point something you will get the answer for this question. 17 point something. Sir, I1 we need to find. No. Vishwanath Murli, because it is this type of question, numerical answer, round off to what? 2 decimal places, right? Means you have to find the value. It is not too high. If it is too high, then they will give you, then it will be given in the question, right? If suppose we are neglecting the beta, then what about the base current? Base current will become negligible, right? And once the base current is negligible, you can make it 0 and then you can find the value, right? And what will be the range? Suppose it is negligible as compared to that value, then we can neglect it. Numerical answer type question, no? Right. Once you are making the IB is equal to 0, then yes, you can take some approximation that let IC is equal to what? IE. In this question, what is the IC or IE? There is not too much difference. But what about that current? R1 and R2 current through that. You have to check this. Okay. Okay, that is the method. I think that is clear to you everyone. This is the, but proper KVL here we are applying, then we are at this point we are applying the KCL. Incoming is equal to what? Outgoing. Remember, when we want unknown resistor, find the voltage and then find the current through that resistor. So around 17 point something you will get the answer. Now, already I have solved this question in 2014. Watch the previous year paper in 2014, similar question on this diagram. CMOS symmetric trigger inverter, already I have given the answer for this question. That is the waveform. This one, right. Find the frequency. Everything is solved here, then find the frequency here. Now, last question. Tomorrow at the same time, please subscribe the channel. Please join the session sharp at 6 PM tomorrow for analog part 2. Please try to solve this question. Last one. Last question. The components in the circuit shown below are ideal. Which components are ideal? Operational amplifier is ideal, resistors are ideal, and so on. If the operational amplifier is in positive feedback and the input voltage Vi is a sine wave of the amplitude 1 volt, the output voltage V0. This is in 2020. That is the question in 2020. Tomorrow I will solve some questions from what? Instrumentation branch. A good question in instrumentation branch. That is important for electrical and electronics branch also. Okay. So on questions on operational amplifier, questions on what biasing, biased current, and so on. Now, components. Now, my dear friend, some student will, what is this, inverting operational amplifier or non-inverting operational amplifier or any other than that, right? So it is not a inverting amplifier or non-inverting. Why? It is what? Symmetric trigger circuit. Actually it is a symmetric trigger circuit. Here we are giving the Vi 1 kilo ohm, 1 kilo ohm. We are connecting the positive feedback is there. Positive feedback is there. So non-inverted sine wave wrong and inverted sine wave wrong. Now we are going to get the two answers, square wave or what? A constant value. What about this diagram? This diagram is a standard circuit for the symmetric trigger. Then this is the diagram. Here we are giving the positive feedback. 1 kilo ohm, 1 kilo ohm. This is the positive feedback. And this is connected to what? Ground. Watch this diagram. Negative terminal is connected to ground. Here we are connecting the Vi with the positive terminal. This is the Vi. Now, what is the supply voltage? Plus 5 and minus 5. Minus 5, this is the V0. If the supply are same, if the resistor are same, then what is the threshold voltage at this point? We have to find the threshold voltage. There is a positive feedback. Yes. And that's why this is nothing but symmetric trigger circuit or practical comparator. Okay. Then first of all, find the voltage at this point. We are having the similar voltage. So what is the voltage at this point in terms of Vi and in terms of V0? You can write the KCL at this point. Remember, the current enter into the operational amplifier is 0. Then we can find the VB is equal to V0 into this resistor. V0 into, I am just writing a general formula. This is the R1, this is the R2. So V0 into this resistor R2 divided by R1 plus R2. This is called shortcut, simple, or I am applying the voltage division rule. Vi into R1 divided by R1 plus R2. Okay, you will get this value. How we are going to get the threshold voltage? Simply just remember, then this is the formula. Then we are having the two values of V0 because there is a positive feedback. There will be the saturation only plus 5 or minus 5. For plus 5, it will become R2 upon R1 plus R2 plus Vi into R1 upon R1 plus R2. Now equate it to what? Negative terminal voltage. What is the negative terminal voltage? 0 here. For example, if it is 2 volt, my dear, equate it to 2 volt. If it is 3 volt, then equate it to 3 volt. But if it is 0 volt, then equate it to 0 volt. Equate it to 0 volt and then find the value of Vi. So you will get the general answer for Vi is equal to minus R2 by R1 into 5. What is the 5? It is nothing but positive plus Vset. V0 is equal to Vset is equal to what? 5 volt. So that is the general formula. Similarly, when we are putting the V0 is equal to minus Vset, that is minus 5 volt, and equate it to 0 from this formula, so it will become R2 upon R1 plus R2 plus Vi into R1 upon R1 plus R2. Equate it to 0. When I am equating it to 0, this will become 0, and again you will get the second level, that is called threshold. It will become Vi is equal to R2 upon R1 into Vset. R2 upon R1 into Vset. Now, what is the standard answer for this question? For this diagram, remember one thing, upper threshold level. This is called upper threshold because it is a higher value. So this is the R2 upon R1. What is the R2 upon R1? R2 is 1 kilo ohm, R1 is 1 kilo ohm. So R2 upon R1 will become 1. So this will become what? Plus 5 volt. And what is the low? This is called upper threshold. And what is the lower threshold? Minus R2 by R1 into Vset. R2 and R1 are equal. Right? It will become minus 5 volt. So upper threshold level is 5 volt and lower threshold level is what? Minus 5 volt. That is not 2 and 5 volt. Okay. This point is clear? This point is clear, my dear students. Am I correct? तो इक्वेट करो ना, इक्वेट करो. आपको दिख रहा है वहां पर साफ साफ R2 by R1, R2 by R1, equate it to 0, equate it to 0, you will get this answer. Now R2 by R1 plus R2, that formula will not work, my dear. That will not work here because Vi is not connected to inverting terminal. Vi is connected to what? Non-inverting terminal. First of all, find the voltage at this point. For two values of V0, one for plus Vset, one for minus Vset, equate the voltage at this point to 0 and then find the value of Vi. For which value of Vi it will become 0, and then you will get the two values of Vi. Lower value is called lower threshold and upper value is called what? Upper threshold. Okay. Once you will get the upper threshold and lower threshold, what is the range of the input? It is between 1 volt and minus 1 volt. Means it will not going to cross the upper threshold and lower threshold. It is not going to cross the upper threshold or what? Lower threshold. Then, for example, if it is a upper threshold level, it is a lower threshold level. What about the input? Input is in between these two. 1 volt only. Minus 1. It will not cross the threshold level. So once the output is once the output is 5 volt, it will remain at 5 volt because it will not change. Or once the output initially it is minus 5 volt, it will remain at minus 5 volt because input will not cross the threshold levels. So what is the answer? Output is constant. Constant of either 5 volt or minus 5 volt. If you want a square wave, then input should increase as well as decrease. No doubt. It will satisfy one condition. It is increasing as well as decreasing, but it should cross what? Threshold levels, upper threshold and lower threshold, but it is not crossing, and that's why output may be plus 5 or minus 5 volt. I think that is clear. This point is clear. The answer is the D for this. Okay, this is about the CMOS trigger. Again, there are two types of CMOS trigger. In one case, it is converted to input is connected to non-inverting terminal. In other case, it is connected to inverting terminal. Only two diagrams are important on CMOS trigger. Okay then. So this is all about the circuit. So tomorrow we will discuss more question, some important question like this is the homework for you. Try to solve this question. So you will get the shortcut of this circuit. How to solve. How we are getting the minor RC parallel with RE, RC parallel with RL. Upon what? Small re. Directly you will get the answer. And what is the formula for RE? VT by IE. How? Tomorrow I will discuss. Directly you will get the answer from this. VT by IE. In one step, within 30 seconds, you will get the answer for this formula. Then, similar type of question in operational amplifier, similar type of question in MOSFET. For example, that is the case, how to get the Norton's equivalent circuit from small signal model in MOSFET, in case of MOSFET. What is the answer? Already I have given you the idea about what circuit. Then this type of circuit, for example, what is the gain of this when we are connecting the different transistor and one Zener diode? Then what is the answer for this type of question? Now, so already almost 21, 22 is over. 20, 19 and 18 we will solve question. Okay, we have to maintain the speed also, no problem. But tomorrow join the session part 2 at sharp at 6 p.m. Then this is for you. 1 minute. A gate and EAC test series, get unlimited access to full length mock subject test. Link is given in the description box. This is the time for what? Mock test. Okay. अगर आपकी प्रिपरेशन हो गई है तो आप ध्यान रखिए, जितना आप टेस्ट देंगे तो आपको आइडिया लगेगा कि आपसे क्वेश्चन बन रहा है या नहीं बन रहा है. लेकिन पहले आप प्रीवियस ईयर क्वेश्चन सॉल्व कीजिए और उसके साथ साथ आप क्या दीजिए? मॉक टेस्ट. और कल मैंने एक सेशन लिया था 45 मार्क्स इन 45 डेज. तो जिन्होंने नहीं देखा है वो देखिएगा, आपको समझ में आएगा कि अगर हमने जीरो से भी स्टार्ट किया है तो हम कैसे 45 मार्क्स टेक्निकल में ला सकते हैं, प्लस 20 मार्क्स इन मैथमेटिक्स. If we are going to get the 65 or 70, then you are going to get the good rank in GATE 2023. बहुत अच्छी रैंक आ जाएगी आपकी. तो आप ये टेस्ट सीरीज ज्वाइन कर सकते हैं. दूसरा, one minute, okay. And this is in a test series, 60 tests covering the GATE and EAC. That is curated by the GATE expert. Detailed mock analysis, there will video solution will be available to you. Virtual scientific calculator is available. 4,000 plus practice questions. All India open mocks are available here. Okay then. This is all about from my side. Thank you for attending the session. Thank you very much. You are on BYJU'S Exam Prep. Please like the session, right? And subscribe our channel. Thank you and good day.